Hi there, I'm Chris Saunders from UniSA. Here we are with a trailer we've put together for the Mallee research updates. So this month we've been touring around the Mallee, talking to farmers and growers about ripping technology and inclusion plate technology. In this video today we're going to have a look at some of the tines that are available, what we can expect to achieve with those tines and how they work in the soil conditions. Okay, so if we take a look at this tine here, this is a conventional straight leg tine. This model is actually by Tilco, it's their longer tine. So as you can see, we have a straight shank, and on the bottom of that shank we have a foot or a point. So the way this ripper is going to work is that this point or tip of the tine is going to do the majority of the breakout and the soil failure. And that soil is going to fail forwards from this point approximately 45 degrees and also to the side. What this leaves is the leg to run through that broken, loosened soil, adding, the smaller part of the forces. So the majority of the forces will come from this point, doing the breaking and the shattering, the lifting of the soil, and then a small component from the leg being dragged through the soil. You'll notice from the point here that we have a low rake angle, so it's very flat towards the direction of travel, and that is good for penetration and also getting some vertical movement of that soil to lift it and break it. So this is the longer of the Tilco tines. There's also a shorter version available, but basically the length of the tine needs to be chosen to reach the depth of ripping that you require. So if you know you have a soil constraint that is deep in the profile, say 500 or 600 millimeters deep, you need to be going for a longer tine such as this one to make sure that you can get down to that depth in the profile without getting the soil disturbance hitting the ripper frame or the beams, the toolbars that this is attached to. There are a range of other straight leg tines available, obviously not just Tilco, AgroPlow, Gießen, and Ausplow, and also there are some other European tines now being available by some distributors in Australia. So back here looking at this straight leg tine from Tilco, one of the things that we can do to achieve an increased area of breakout is to add something called a wing. Now these are some wings that we made because at the time there weren't any available from the manufacturer, but essentially these wings bolt to the bottom of the shank here as such, okay, and basically continue this soil failure that the tip has created, lifting the soil here and also increasing the width of breakout. So what we end up with is an increased width of breakout at the bottom of the tine at its working depth and an increased loosened volume overall. So we can increase the loosened area by about 50% by adding these wings. And in some research that we've done, we found it was only about 20% increase, 20 to 25% increase in the draft force required to pull this tine through the soil. So we get a benefit there in increased loosened area for not much draft force penalty. So in contrast to the straight leg tine, here you can see what we call a parabolic tine. So you can see the front edge of this tine is very curved, taking the point forwards of the main shank. This is still vertical in the direction of travel, but the face here, the curved face here, gives more upward lift and also some slight amount of mixing as the soil is pushed up this face as the ripper moves through the soil. This is a grizzly tine, and there are a few other parabolic options available, and these are normally orientated on the ripper frame in a V formation, so one leading tine in the center with staggered tines either side. So this tine style is slightly different. So what we've looked at so far are traditional sort of subsoiling ripping tines, which are good at loosening soil at depth. This tine is designed to do something slightly different. It will give you a ripping action, but it'll also give you a lot of mixing action. So you can see with this straight leg tine, we've got a sort of constant angle from the tip up the shank, around 40 degrees maybe, and a big wide point on this tine at a more aggressive angle. So this is going to give you a lot of uplift on the soil, a lot of sort of mixing, and again on this one they fitted an additional shin plate which has got a knife edge here, so if you've got a more heavy soil, it's bringing up clods, this is going to cut the clods in and break them down into smaller pieces, and additionally they've got some wings added on the side here which are just for clod breaking and more mixing. So this is a Dondi tine, and Bednar Terralands have similar tines to this, and conventionally these you see them in ranks of multiple operations, so in a combination machine. So you might have a row of tines like this in front, maybe a smaller set of tines behind, and then some either discs or crumbler rollers to break up those clods and to finalize the mixing and to leave a level surface. And again, due to the upward mixing of this one, I'm not sure, I haven't seen an inclusion plate added to these tines yet either, because this is going to do a lot more disturbance in front of the tine, and therefore not leave you any soil to fall back down in that inclusion plate process. So looking at this tine, we're looking at slightly different technology here. This is an AgriSem tine out of Europe again, and you'll notice with this one that this has got an extended wide foot and very long foot, slightly offset to the side of the shank. Manufacturers claim up to 25 to 28% draft reduction from this type of ripping tine. And again, you'll see a very low rake angle on the foot, very wide, so we get good breakout of soil here. The shank is led by these tapered shin plates, so low resistance through the soil. But the effect of this large wide foot is more of a wave lift of the ripping action. So if these tines are side by side on a rank, the soil comes up to the tine, breaks, rises over in a wave, and then goes back down. So we're looking at very low soil disturbance on the surface with these tines, but because of the big foot underneath, it's lifted that soil underneath and caused it to break up and fracture and loosen the compaction that you're chasing. So again, with this tine, because of the design, there's probably not much option to add an inclusion plate if you're considering that as one of your amelioration techniques. So we've looked at a couple of straight leg tines and also the parabolic, but now if we take a look at this tine, we'll notice that it's actually got a curve to the side of the shank. So we have a straight section of the shank here, and then we have a curved part of the leg with a curved shin here. This is a Michel tine from Europe and actually distributed by Williams Agri now in Australia. This tine is claimed to be a lower disturbance, slightly lower disturbance tine, and also a slightly lower draft force tine potentially. As we saw earlier with the straight leg tines, the soil is lifted off of the tip predominantly and lifted upwards and forwards of the tine. Obviously, so with this one being at an angle to the side, some of that soil is pushed to the side and actually follows that natural 45-degree failure. And hence with the leg here running at this side angle or curve, the aim of this is this shank and this shin will run in the natural soil failure that comes away from the tip here at 45 degrees. So this leg is in a broken plane of soil failure and therefore hopefully reducing the draft force to pull this ripper through the ground. Obviously with a curved tine like this, if you're considering inclusion plates, this is more difficult because the inclusion plate won't be running directly behind the leg of the tine, so probably not a good option if you're thinking about adding an inclusion plate, whereas the straight leg tines are more suited to adding inclusion, although I haven't seen at this stage an inclusion plate behind the parabolic tine.